Okay, so I think we're live. Yeah, we're live. So hello, everyone. Thank you for another live session of Tubonomic Labs. My name is Jacob and David. I'm from Tubonomic Technical Marketing Team, responsible for everything cloud. So thank you very much for joining us today on LinkedIn, YouTube, Netflix, HBO, and other streaming sessions. So we appreciate your coming in today. So today's session, so basically, let's start with what Tubonomic Labs are all about. Um, our sessions are designed for you, the practitioners, the people who are dealing with the challenges on the field, with the hands-on on the equipment. These are sessions for the community, Tubonomic users, or just people who want to explore and see what Tubonomic is all about. So that's Tubonomic Labs. We have it weekly. Make sure to join us on tubonomic.com/labs. That's where we're going to see all the information, all the previous sessions, and additional information on how to use your Tubonomic and also enhance your technical skills around the IT industry. So, as I mentioned, my name is Jacob, and I'm here in Canada, based in Toronto, and I would love to show you today and discuss how you can achieve truly optimized cloud where we say performance first. And I want to highlight and show you a little bit today what it's performance first. What does that mean, and how does that differ than other tools out there and approaches, for example, where people are just trying to reduce cost at all costs. So without further ado, let me jump into, I think I didn't prepare any slides. So here you can see my screen, hello screen. And oh, it's getting bigger, that's good. So now let's take you through a quick tour of our platform. I'm going to show you two systems. There will be the Tubonomic SaaS platform, which we see today. So if you didn't know, Tubonomic is either offered as a self-service platform that you can deploy. It's an OVA. You just quickly deploy it on your environment. It takes about 30 minutes to deploy Tubonomic. Extremely easy, just OVA. You configure the IP, and then you start adding targets. And I'll show you that how it's done. And as I mentioned, we have also the Tubonomic SaaS platform, where it's fully managed by Tubonomic experts, fully secure, running on the cloud. All you need to do is, obviously, because it's running on the cloud, the current stage of a SaaS is focusing on cloud optimization. And in the future, we'll also offer the ability to do hybrid control like we offer from our second solution. So let me quickly jump into the second tab. So this is a Tubonomic server, self-managed, running on premises. So as a fully hybrid platform, Tubonomic can control and optimize both on-prem and cloud. But one thing you noticed at both platforms, so if I'll jump back into our, oh, that's the Tubonomic Lab page. So if I'll jump back into the SaaS platform, you'll see that both screens start with applications. And the reason, that's one of our unique approach for Tubonomic. We are here to assure application performance. And assuring application performance is to ensure that we, first of all, understand what applications are. A lot of solutions use the term applications based on, understanding of CPU and memory, but that's not what really applications are all about. That's not gives you the access to truly understand what applications require and how they're structured. So as you can see here, we've ability to integrate with application performance monitoring tools or management tool, depends who you ask, APM tools. That includes App Dynamics, Dynatrace, Microsoft Application Insights, New Relic, and we also have the ability to ingest any APM, even if we don't have out-of-the-box support, and I'll show you how it looks like. By doing so, we really gain insight in your business applications. So you can see a list of business applications. We will display the health state of the applications. And we have the ability also, by integrating with the APMs, to understand the response time application, which is a very important key indicator for how applications are performing in your environment. And we also have the ability to understand the business transactions. So you have your holistic applications, but each application is consisted of multiple transactions. For example, you have your API front end, you have, for example, your retail cart transaction, or anything else like that, or the system that interface with the credit or the payment systems. These are transactions, and it's very important to be able to understand the breakdown. So Tubonomic has full, so you can see here we have inventory transaction and additional breakdowns of that. And lastly, understanding of the services. And by doing so, we are truly understand what the application needs and what is required to provide the application the resource it needs to perform continuously. This is not a one-time endeavor. So as you can see here, we have this application that is running. And if I click on it, you can see the breakdown. So here's the single focus on an application. I can see all the resources here. I can see the average response time. Obviously, this application is not very active, but there is still risk in the environment. So imagine where you're working IT operations, someone calls in, hey, my application is not performing. I see that, or it's not loading, or it's very slow. By just simply searching for the application. So if I'll go here, that's really powerful ability. So if I go into business applications, if I click that properly, there we go. And I can search for every application. So you can see the list, but you can filter them. And let me go back to the same application that I was there. So here's the Sonoran, and the same aspect, the same view. So ability to quickly locate the application, see if there's any risk factor within, just without even looking at any logs. You know that there is a risk here on one of the business transactions, but it's rooted. If you look down from the top down, usually the bottom starts from the bottom up. So here we can see we have 2 VMs out of 3 that are suffering from issues. And as you can see here, there are 2 VMs that are running with resource contention. And if I'll expand that, you can see that this is a VM that is running really high on the memory. And we have the ability to truly, and because of obviously memory is enabled here, that's really important, and we'll discuss why it's important to really optimize your cloud properly. You can see that Turbonomic is able to suggest to move between tiers. This is actually running on Azure. So we're moving between service tiers. Here's another example where we suggest to move from B2S to B2MS in order to provide the requirement. And we have a truly understanding of the CPU, and every decision that is generated by Turbonomic on the cloud is considering multiple metrics and constraints. So obviously you see the obvious ones. There is the vCPU, the memory, the IO throughput, but there are also elements behind the scenes that you don't see or we don't expose. For example, understanding how many NICs the VM has, or what's the IOPS utilization of the storage across all storage, where we generate an action to size to your new instance. So here's, for example, the ability to do so on Azure. But let me kind of go back a little. And how did we reach that state of Turbonomic truly understand the applications and have the insights of what's need to be done on the cloud, and creates that inventory and the supply chain that you see here in front of you? So if I'll go back into the Turbonomic settings screen, so once you deploy Turbonomic and you have access to the user interface, the first thing that you need to do is add targets. And here again, I'm on the SaaS platform, so obviously I'm only going to have cloud-based targets, and I'll show you the other where you see the full specs of the targets. But here you can see we have the ability to quickly add AWS. This is the AWS billing. So adding this target only going to add the ability to display your AWS bill, and that gives us the ability for breakdown, for example, by top accounts, who is consuming the most costs, or generating the most costs on your AWS or specific service. You can see you spending X amount on Lambda, and you may spending X amount on EC2 and other services. So that's the billing visibility capability are enabled by adding the AWS billing. And basically, that's what you need to provide is the cost and usage report, or known as the curve file, on an S3 bucket, and just give us the access to it, and we'll be able to parse it and display the billing information. Also, you can see here we have an AWS target. This is your regular AWS accounts where there have VMs running and either services, for example, EC2 or RDS, or containers, for example, on EKS that you want us to optimize. So just simply provide us with the API keys or IAM user role you generate. We have basically we require EC2 access, RDS access, and S3 access if this is a billing account. And it's the level of permissions that varies. If you want us just to show you actions, show you the recommendations without taking action, it's read only. But if you want us to take actions natively against your environment, to size it or stop it or take actions, again, we require full access or reverse specific permissions on the cloud. So we just need the API keys added in Tubenomic. And obviously, I forgot to mention, it's very important that we also have the ability to integrate with Azure, another major cloud provider in the field. So we have the Azure Service Principal. This is how you add all the subscriptions to Tubenomic. You can have one service principal that defined, and again, it's an application ID. And let me kind of quickly click on it and show you how it looks like. So you provide us with the directory ID, the application ID, and the secret key. That's basically the application. And if this application have access to multiple subscriptions, we will automatically discover all the associated subscriptions, and we'll show you what else we discover when you add this. But it's also important to note that some organizations, specifically enterprises, have Microsoft Enterprise Agreement. By adding this target, which is very simple, you just add the enrollment number and the API key. We have videos if you're curious to see how it's done, very simple. And by doing so, that gives us access to your rate cards, so negotiated rates that you have with Microsoft. And that gives us also ability to understand the cross-account structure of across all subscriptions, and also ability to understand the reserved instance utilization, which will show you why it's really important and powerful to enable that on your cloud environment, because that's another way to save cost and assure performance of your cloud. And obviously, there's additional targets. So here you can see this is one of the custom ones that we can add, like Prometheus. But if I'll go into the application, you can see all the APMs I mentioned earlier. These are the options that gives us access to your application performance. So we can see the heap size, the database memory, the Java garbage time collections. Those are elements that really help us to optimize not just the resources that are assigned to the application, but also you'll see application recommendation themselves, resizing the heap size on a Java server. That's really powerful. And you'll see that also in today's demonstration. And you can see these are really all the APMs that we have today out of the box. That will probably grow. And if I'll switch back into the system, the on-prem system where it's kind of more open because the SaaS, as I mentioned, is targeting cloud targets. Here you can see additional elements. So we can see we have hyper-converged, like Nutanix. Or we can have control your hypervisors like Hyper-V and vCenter. If you want to optimize environments like VMware, that's the way to do it. And we also have the ability to do action scripts, but also if you have VMM, Virtual Machine Manager for Hyper-V, we can control it. But what I want to show you is this. This is the data ingestion framework. This is the element, for example, let's say using an APM that we do not support right now. For example, Solaris Winds. So if you want to ingest data from Solaris Winds, this is your method, for example, until we're officially going to add support for it at some point in the future. So the data ingestion framework essentially allows us to connect to a location and where you expose, for example, a file that kind of feeds data from a source like SolarWinds, and we can import all this data and show the same understanding of the application level from within the environment, and then generate actions that are taking also this telemetry into consideration. Extremely powerful. And once you add all these targets, you'll see this created within 30 minutes. This is what we call the supply chain. The supply chain represents the top-down view going from the applications down and showing the relationships. These are all the arrows that you see that show the relationships and the trade-offs also between various components within your IT stack. This is your IT stack across both on-prem and cloud, for example, in this environment. It's a truly hybrid control platform designed to manage everything. And everything that is added here is without any agents. Tubenomic is completely API driven. We connect to various targets that I showed you in the previous screen by simply using APIs, the native APIs of each vendor. That's what we call the targets we create out of the box. And you can see either if your applications are based on VMs or containers We can truly optimize it. And for containers, you can see that we also provide you with a true breakdown of the container structures. For example, the container specs. These are all the configuration that are controlling the size of your pods and containers, or the controller, or the workload controller. This is, for example, if you look at in Kubernetes YAML file, this is where you define, for example, the type of the workload, and obviously, excuse me, the namespaces. So for example, if I click here, I can see various namespaces that are running in this environment, and even Tubonomic itself, application, the Tubonomic server, is shipped as a containerized. Tubonomic, our latest versions, version 7 and up, is based on containers, so it's a microservices. Our classic version of Tubonomic in the last 10 years is based on monolithic Java. So we also modernized and transformed our application, which gives us multiple benefits, which will require another session just to explain what are the benefits of moving to microservices architecture, which a lot of companies are going through. And by doing so, we also learned a lot by ourselves on the challenges that people are going through when they optimize or they're controlling and optimize microservices applications. So you can see here, Tubonomic is, so basically, this is a representation of the Tubonomic applications. I can see that the server, there are some areas where it could be probably be better. So I could also click on containers and see some of the actions. So all the actions here are basically saying that some of the applications are oversized. So I could definitely reduce and reclaim some resources. And you can see the actions that we generate to resize requests and memory allocations for various containers. And we also have actions, for example, to move pods. If you have a cluster, so we can move pods between nodes in the environment, either if it's on-prem or even if running on the cloud. That could be a GKE cluster, that could be an AKS cluster running on Azure, or EKS running on AWS. So that's one of the things that you get from Tubonomic, is that really top-down view of any architecture, of any workloads, VM, containerized, on-prem, or on the cloud. And since today's session is focusing on the cloud, if I will jump into the cloud tab, you can see that Tubonomic is all about actions. And as I mentioned, we are designed to assure performance. So there will be investment. So there will not always going to be, so Tubonomic is not a cost-saving only platform. We will show you that sometimes you're required to invest. You need to add in order to assure performance. And because our application, because our analytics are designed, very simple concept, to align application demand to supply. It's basic economic principle, supply and demand, just to match them. And because most of the workloads in any environment, on-prem and on the cloud, and there's multiple reasons why that happened, that most of the workloads are oversized by design, because that's what a lot of organizations are opting to do when it comes to decide, or when they try to assure performance. You know, the guesswork, what an application will require, they don't know exactly, so there's a lot of guesstimates there, and they're gonna add a little bit of buffer just to make sure that there will be no risk or performance issue. And usually that ends up with substantially oversized workloads. And these are why a lot of customers, when they move their workloads to the cloud, suddenly they're starting to pay for that oversized practice. On-prem, you didn't feel it so much. Maybe the IT team or the CIO felt it when they bought all the equipment they bought more than they needed to, because again, the on-prem was really oversized. But on the cloud, you feel it on a monthly basis because you're paying by the second for what is allocated, not for what you use, for what is allocated. And that's the reason for a lot of complaints, or if you look at all the surveys, what's the number one initiative or challenge is cost optimization. And the reason is that, again, a lot of companies are doing so either because they don't know what application needs, or they don't understand the cloud, or simply they just carry on the practices they had from on-prem of oversized to assure performance. They carry it to the cloud, and until they get the first bill, and suddenly they're starting to, what can I do to address that? So the way to address that is to continuously reassess the environment, continuously. It's not a one-time endeavor. To optimize a cloud has to be done 24/7, and actions needs to be taken. The other approaches of reporting, dashboarding, chargeback, showbacks, they're good. They're valuable to understand why. But if you really want to address and tackle the problem, root cause, not tackle the effects, which is the oversize or costs or runaway bills. These are the side effects. You have to tackle the source, and that's the only way to really achieve a fully optimized cloud. And the way to do it is to take actions. So what are these actions? Let's kind of quickly take us on the action. Let's start with the basic ones. For example, deleting idle resources. In this case, volumes, unattached volumes. And you were surprised how much volumes are out there unattached that not a lot of people know about. And again, this is also related to lack of understanding in the cloud. Sometimes when you delete a VM, for example, on Azure, and you didn't delete all the associated resource, the volume and other elements will be left behind. And these volumes, the VHDs running on Azure, will consume, and you can see here, these are volumes that just sitting there, and I'm paying $11 for this one, or let's kind of try to see if I can find the biggest one. So let me kind of sort by the saving amount and apply. Look at this volume. I'm paying $135 a month just for this volume. This is mind-boggling, and there are more of these. You can see them, and they're just not attached. And by the way, every action or list of actions that you'll see in the product, if you want to take them down and send it to people or do investigations or create reports, you can really create that. You can see I just clicked on that, and that's generating a download. So here's my CSV that I can manipulate and do things with. So that's, again, I could delete this directly from the UI if I wanted. Obviously, I wanted maybe investigation to confirm it's safe, but I could delete it from here, or I could automate the deletion of volumes. And obviously, you don't want to automate any volume just kind of without control. So what you can do is create a dynamic group of volumes that only if they have a specific tag, for example, auto delete equals yes. And you can create a group that automatically updates and dynamically up to date with any VMs that you verified or volumes that you verified, and you can create that tag. And obviously, that's one way to do it. But obviously, most of our customers are just deleting it after doing investigation or downloading and sending them to the owners of each and every volume to make sure they're deleted. So that's one of the ways. And obviously, another way to save money is reserved instance. One of the most typical options or mechanisms on the cloud to save money is using Arise. For example, in AWS, they're shifting from Arise into saving plans. But here you can see some examples of reserved instances in various areas. The difference in Turbonomic is that we are actually showing Arise recommendation based on observed demand. Resource utilization. So we factor in sizing recommendation, where with other solutions, if you see RI recommendations, they will be based on whatever the VMs or the instances are allocated with, which means even if the VM is oversized, they will show you you should buy an RI for it. Where Turbonomic says, no, don't buy RIs for oversized VM. Optimize them first, then buy the RIs. Don't overbuy the RIs. So here you can see an example of how we do it, and we do it at scale per region based on demand. Very powerful and really helps you to achieve a lot of savings. And obviously, one of the most typical ways is scaling, either scaling of databases or scaling of VMs, or obviously scaling, as you saw earlier, scaling of containers. So as you can see here, I have a list of actions. Obviously, the top one are performance. So as you can see, I have a system here. And obviously, it's running on AWS, where it's really running hot. You can see it's 97% CPU utilization percentile. So it means 95% of the time, this VM is running on that utilization. So it's really running hot. So we definitely need to take that. And we're showing you a representation of that utilization over time versus the average. So the purple line is here. We set it to 100th percentile, which is very conservative. But by default, we ship with 95th percentile, which means we shave off the 5% peaks that could be anomalies in the environment. And so you don't want to size to peak. But here, for example, that could be something, maybe a production systems where you only want to size to peaks because you don't want to take any risks. And we're showing the impact of the action. And you can definitely execute that or automate it from within the environment. What you can see is also it's the array utilization. Every action in Tubonomics. So I mentioned multiple metrics like the network I/O and the storage I/O and the memory and CPU. But the reserved instance is, again, another one powerful element that we look at every scale action. We will look at also on your array inventory, and if there's available array that match the target size or close enough to the target size, we will scale that VM to that array. So we're going to save you twice. One, we're going to move your VM from on-demand by the second costs to something that you already paid for. And because you already paid for an array and it's not being used, you're saving money on it. So you're leveraging it. So you're maximizing your investment in the cloud. So let me kind of try to search for, look for scaling actions. So with array to show you an example. So let me just do the keyword increase and show more. So let's see if that's up almost. So in this case, but again, we can see that example where Tubonomic is like a box of chocolates. You know, that's how I like the demos. It's dynamic. It's always changing. Our actions are not static, which is an important point. They're changing as the dynamic. So there could be multiple changes in the actions we generate for a VM based on fluctuation in the demand. So that's really important because that's real-time optimization. It's not like based on yesterday data and the same action will be stuck for the next day and 24 hours refresh. We continuously generating actions for the environment. So you can see in this case, we're moving a VM between two arrays. So we had an array under the T2 Nano, but we noticed that we have a T3 Nano not being used, and it's more applicable for that VM. And we're just going to move it because it's going to give us better utilization of the resource. So that's one example of moving. And sometimes we're going to move arrays, even if it's the VM probably doesn't need it, is because we identified another VM in the environment that will benefit from the T2. So what we're doing, we're moving a VM, and so we're making that array vacant. It's like a massive chase game. It's beyond human scale because the way we do it is across environments, massive environments, hundreds of thousands of VMs running on the cloud, and we do these little calculations about what can really achieve the optimal state, and we do it with steps. We're not trying to boil the ocean at once. So we do it with multiple steps where, for example, this step will remove that. We're going to make that array vacant by giving the VM a better array. And that array, in the next cycle, the VM that require that array will get it. And maybe that VM is on demand. And then you'll see even greater savings over time because we continuously optimize the environment in better states. And as we optimize the environment, if we feel that the environment could benefit from better utilization of arrays, we will recommend to buy arrays. So that's kind of the continuous cycle of multiple actions that are generated by our system. And all these actions obviously can be fully automated. So let me quickly show you how it's done, how easy it is to automate Tubonomics. So it's basically a policy you define. Let's go into VM policy. So for example, if I want to create, first of all, you find which group, so you can create group of VMs because you don't want to apply for sometimes the same policy to the same VM. So you can create grouping of VMs based on tags, on names, ownership, resource groups, any element that you want, and then assign that group to that policy, and that's called the scope. And then you can define a schedule if you want that to happen maybe in a maintenance windows. So you can attach a window, time window, or maybe you want to do it live, so you don't attach. And then simply, for example, just to scale, let me show you how easy it is to scale. If I want to scale automation, I select that, scale compute, automatic, and there's also advanced option if I want to do something before the execution or after the execution. And basically, that's it. I submit, I save, and from this point, I created automation policy in this environment. This is how easy it is to really optimize your cloud environment. And there is so much more we can show you, but we wanted to kind of give you a glimpse within 30 minutes of Tubonomic demos. So hopefully that helped you truly understand what Tubonomic is all about. If you want to learn more, or if you want to try Tubonomic, just head out to tubonomic.com/labs and try Tubonomic. It comes, you can download Tubonomic and you will receive a license, free license for 30 days to try Tubonomic in your environment. And truly simple as I showed you. And just deploy it against your environment, you get a sense of what's possible. And trust me, you will come back for more because as I showed you, we can do public cloud, we can do on-prem, we can do containers. And I'd even show you our planning capabilities, including cloud migration planning, because we are hybrid cloud. So again, there's so much more we can show you, and we will show more and more of our cloud capabilities in upcoming Turbonomic Labs sessions. So make sure to tune in. And thank you again for everyone. Hopefully you found this session useful, and looking forward to see you in upcoming Turbonomic Labs broadcasts. So have a great day, everyone.